So let's take a look at SOLIDWORKS simulation in SOLIDWORKS and see how that will help us design some better parts for the defense industry. Alright, so we've got an analysis already set up here in SOLIDWORKS. It's actually going to be combining both a thermal analysis, or we've applied a temperature. We've then derived the stress from that thermal analysis, right? You know, if you got parts expanding, it can cause a stress. And then we're going to take this static pressure analysis. So we've got a pressure, right, on certain faces of this part. Whenever we run this, running this study will then give us a pressure result, right? So we'll have a stress from our pressure, a stress from our thermal analysis. Now, we're going to take both of these and we're going to apply them in a fatigue study. Now, you may have not ever done this before, but it's a super useful tool whenever you have stuff experiencing high cycle loading and maybe multiple different types of loads, like what we've got here, both a thermal and a fatigue study, or a thermal and a pressure. So now that we've got our results from the static pressure analysis, we can actually take those and we can create a new study called a fatigue study. Now we've got a few different options here to define our fatigue study type. We're just going to choose the constant amplitude. And now we can come in here and start defining our load types. So we're going to add an event. This is going to be the thermal stress. And we want to cycle this 2 million times. Using a zero-based load. Let's add the other event. This other event is going to be the pressure, and we're going to cycle this 1.9 million times. Notice we've got different load ratios and different load types for each of these. And I'll make sure to choose static pressure. Awesome. So we've got all that selected. So when we run this study, it's going to calculate damage, right? So it's giving us a damage percentage. So the best thing to set the damage percentage at is just going to be 100%, right? So essentially, has this part reached 100% of its fatigue life? Now, we're going to ignore this hotspot around the bolt. That's kind of expected. Plus, we've got some contacts due to the way the bolt's set up that we can assume this is a false stress. What we can't necessarily assume is a false stress is this stress right here in the fillet area. So this is basically telling us this plot has taken our thermal load, has taken our pressure load, it's combined them, and it's applied them millions of times, and is now telling us if we're going to have any failures due to fatigue. And at this point, it looks like we are going to have, or we're very close to having, a failure due to fatigue on the fillet. So this is a great application for using this fatigue study because we have multiple loads going on here. It's a little bit more of a complex situation.